meters, built on an artificial island in the Arabian Sea in 5 years. This was the site in 1994. Open water, not a piling, not a grain of dry land.
The first thing that hits you walking across this bridge is that the ground under the hotel was created by humans. The sea didn't want to give this up.
Sheikh Mohammed wanted one image, one building, something the world would know before it knew Dubai. Architect Tom Wright drew the concept in 1993, a dhow sail, one of the oldest shapes in Arab seafaring, designed by Atkins, built by Murray and Roberts and Al Habtoor Engineering. 2,000 workers, $1 billion. Before one beam went up, workers had to build the ground beneath it, from scratch, in open sea. 230 concrete piles, 3 years to build the island, then less than 3 to build the tower. The most photographed hotel on Earth, built step by step, starting with the sea floor. July 8, 1994. Position marked with buoys, 280 meters from the beach. Nothing exists yet. A pile-driving barge anchors over the seabed. Workers rig the hydraulic hammer. First pile, ready. Each pile, 40 meters long, 1.5 meters in diameter, 230 of them, all into the seabed. The hammer strikes. Each blow drives deeper, through sand, through silt, down toward bedrock. Bedrock is over 180 meters down, too deep. The piles must grip the sand itself. There is no bedrock to land on, friction piles only, gripping the sand along their full 40-meter length. Slowly, a forest of concrete grows from the sea, pile by pile. The island is invisible, but its skeleton is there. Temporary sheet piles ring the footprint. They hold back the sea while the permanent island builds inside. Rock buns dropped on both sides. The island edge has to resist 100-year storm waves.
Standing in a boat surrounded by these pileheads, you realize the island doesn't exist yet. These are the roots of a building, not a foundation for land.
Concrete shed armor blocks around the perimeter, first time in Gulf construction. Designed to absorb wave energy. 2 rigs working simultaneously. 230 piles to drive. The schedule allows no waiting. Every pile load tested before the raft goes on. 1 weak pile here, and 70,000 tons shifts. 230 piles complete. The sea floor rearranged. Now, the land itself must be created. Hydraulic fill pumped between the pile walls. Sand and water sprayed in until the sea is displaced. Workers measure the fill level every hour. Too fast and the sheet piles buckle. Too slow and the schedule breaks. Over weeks, the slurry settles, the water drains, and for the first time, land appears where only sea existed. Vibratory compaction probes driven into the fill. Loose, saturated sand can't carry a building. This forces it dense. Armor rock laid over the fill surface, large enough to resist waves, heavy enough to stay. Concrete honeycomb blocks ring the island. First time in Gulf history. Wave energy bleeds through, instead of slamming the island.
This ground didn't exist 3 months ago. I'm standing on sand that was seabed. The Arabian Gulf is right there, held back by those blocks.
The seawall rises to 7.5 meters above sea level. The lowest floors sit behind this wall. A 100-year storm cannot reach them. Drainage pipes buried in the fill. Groundwater has to go somewhere. Pile heads trimmed to exact level. The raft must sit flat. Every pile cut to within 5 millimeters. Blinding concrete poured over the full base. The floor workers will stand on, also part of the structure. Waterproof membrane heat welded over the full base. The Gulf will try to push water up through here for 100 years. Raft formwork goes up around the perimeter, 70,000 tons of concrete, marked out in timber and steel. The island is ready, dry, stable, waterproofed. 2 years of sea work for this platform in the Gulf. The rebar starts, hundreds of workers tying steel across the full footprint. This cage becomes the skeleton of the raft. Every pile head wrapped in rebar. The raft grips every pile. Load shared between all 230. Pile cap cages lowered over each cluster. The cap distributes column load between piles. every tie made by hand. The first concrete pour begins, 70,000 cubic meters. The pour starts, and it does not stop. Vibrators driven through every pour. A void in this raft is a fault the building sits on, every centimeter covered. Night shift. The pour continues. Any stop means a cold joint, a weak plane, forever. Laser-guided screeds drag the surface flat. Every column that rises from this starts from the same plane. Cooling pipes cast inside the raft. Concrete generates heat as it sets. Without these pipes, it cracks from within. Temperature logged every hour. Keep the interior below 70 degrees. The pipes run cold water for weeks. Wet Hessian burlap across the full surface. Too fast, it shrinks. Too dry, it cracks. Water stop joints cut at calculated intervals. The raft expands and contracts with temperature. The joints let it move, safely.
More than 70,000 tons of concrete, poured in one continuous operation on an island humans made. And the building hasn't started yet.
Column starter bars drilled and grouted into the raft. Every location set from the building's survey grid. Epoxy coating sealed over the full raft. Seawater and salt air. For 100 years. The raft is complete. 230 piles below. 70,000 tons above. Now, the hotel rises. Jump form formwork assembled at the core. It climbs the building as the walls rise. No scaffolding from ground to top. First core wall pour. Every floor, every load, every storm force, carried by what's being poured right now. Jump form jacks up. The formwork lifts itself floor by floor. Workers ride it up the building they're building. Table forms fly into position, each one 18 meters long. No shoring from below. They hang from the wall. Post-tension tendon ducts across every slab. Meinhardt International re-engineered every floor. Less steel, faster cycle. PT strand threaded through every duct. After the pour, these strands get stressed. The slab grips itself. Tendons stressed from the slab edge. Each strand pulled to design tension. Jack releases. Concrete permanently in compression. Table forms stripped and flown to the next floor. Same form, next floor, every time. Floor by floor, pour, stress, strip, fly forms up. Workers do it 56 times. Exoskeleton anchor plates cast into the core walls. The steel frame bolts here, precisely located once, forever. Service sleeves cast through every wall, pipes, cables, ducts. Cut them in later, and the structure is weakened. Half-core walls at 250 meters. The gulf 400 meters in every direction, nowhere to step back to. The final core pour. Jump form stripped for the last time. The core stands 321 meters above the sea. 130,000 tons on 230 piles in the Arabian Gulf. Naked, unclad, already iconic. 9,000 tons of structural steel by barge. The exoskeleton and the outer frame starts here. First exoskeleton beam lifted into position, bolted to the anchor plates cast weeks earlier. The outer frame begins. Every bolt torqued to specification. The exoskeleton resists the full wind loading. Every bolt carries that force. Workers climb the exoskeleton face. No elevator, no scaffolding, just the steel grid and a harness over the gulf. The diagonal cross-bracing goes in. Lateral wind load. At 300 meters, gulf winds are constant and enormous. Cross-bracing bolted in. 2 workers, one at each end, simultaneously. The frame doubles in stiffness with each brace.
This steel on the outside isn't decoration, it's structure. The whole building leans on this frame when the Gulf wind hits it. Every beam is doing real work.
The Al-Muntaha arm extends 27 meters from the south face, bolted section by section, 200 meters above the water. Every bolt here carries the floor, the guests, the kitchen, cantilevered 27 meters over the sea. From the air, the arm looks impossibly slender. On paper, it's over-engineered, that's the point. The helipad at level 59, 210 meters. Workers bolt the radial beams to the ring girder. Deck plates bolted, landing circle marked. Workers on this deck are standing over nothing but sea. The mast top goes up, 315 meters, the last structural steel. Sail connection points ready, wind bracing across the atrium opening. The north face stays open, but carries wind as if it were closed. Last major exoskeleton panel lifted from barge level. Workers receive it. The steel frame is almost complete. Teflon-coated woven fiberglass, PTFE on both sides. Gulf sun, salt spray, 50-degree heat, for a century. Each panel cut to the exact geometry of the exoskeleton grid. The building curves. No two cuts the same. Edge fittings crimped onto every panel. These carry the full tension load when the panel is stretched across the frame. First panel goes up, workers unfolding it on the scaffold. The first piece of the sail, on the building.
This fabric in full sunlight glows. At night, the building becomes a lantern, one material doing both jobs. That was the whole design.
Turnbuckles tightened at each corner. The fabric goes taut. The building looks like a sail for the first time. 12 atrium membrane panels, each double layer, each individually tensioned, facing north to keep direct sun out of the atrium. Tensioning cables stressed on every atrium panel. Wind load carried through these cables to the structure behind. The white sail climbs the building panel by panel. Below, done. Above, bare steel. The transformation in real time. Workers tap every panel surface. A slack panel flutters in Gulf wind. A panel that flutters, fails within a year. Panel joints sealed with specialist compound. Salt spray behind the sail corrodes the exoskeleton steel. Final sail panels at the mast top, 300 meters above the Gulf, rigging the last connections. The sail takes form. The image Sheikh Mohammed asked for in 1993, over Dubai for the first time. Night installation. The building glows for the first time. The Teflon fabric becomes a screen for the light inside. Dawn. The sail is complete. 321 meters of Teflon-clad steel and concrete standing in the Gulf.